Hello everyone, this is Amika Mahajan. Welcome to my channel. This video is focused on dimensional analysis. In this video, I am going to discuss application of dimension analysis. I will take one application to check the correctness of physical relation using principle of homogeneity. Already we have done this principle that dimensions of different terms of a correct physical relation should be same. Now, first, I take the question in which to check the correctness of given physical relation t equal to 2 pi L by G square root, where t is time period, L is length of pendulum, and G is acceleration due to gravity. Now here two terms are there. One is left side, another one is right hand side. Here L and G, they are in divisible form. So this will be only one term. Okay, these are two factors on which this time period is depending. So first of all, take left hand side, dimensions of time period will be capital T. Now take right hand side, 2 pi L by G square root. This can be written as 2 pi L by G whole power half. This square root represents half power. Now we can write dimensions of length and G. So length is L. G is L t ki power minus 2 because it is in square root, so whole power half. When I solve it, it comes out to be L half divided by L half, t minus 2 into half. It will be t ki power minus 1. This L half will cancel with this L half. So what is left? 1 by t ki power minus 1. So when I take reciprocal, it comes out to be t. So what we find? Dimensions of left hand side are same as that of dimension of right hand side. And by principle of homogeneity, if all terms are having same dimension, then that relation is dimensionally correct. So given formula is dimensionally correct. Now come to second question. Here another relation is there. Centripetal force F equal to mv square by r, where m is mass, v is velocity, r is radius. First of all, we will see how many terms are there. There are two terms. Both terms should be having same dimension. On right hand side, it is mv square by r. These are the three quantities on which this force is depending. And mv square by r collectively make one term. So first left hand side dimensions of f will be ml t की power minus 2. यहाँ पे क्या है? f equal to mv square by r. राइट साइड पे m into v square by r. ये मिलके एक टर्म बना रहे हैं. जहाँ मल्टीप्लाई और डिवाइड का साइन होता है वो एक टर्म है, और इस इक्वल के लेफ्ट हैंड साइड पे एक टर्म है. तो पहले हमने लेफ्ट हैंड साइड टर्म का डायमेंशन पुट किया. अब हम राइट हैंड साइड पे आएंगे. मास विल बी हैविंग डायमेंशन m, we will be having dimension L t की power minus 1. आगे ये स्क्वायर टर्म है, so whole square divided by radius will be L. अब यहाँ पे इसको कैसे लिख सकते हैं? M L की पावर स्क्वायर, ये पावर अंदर चली जाएगी. t की पावर minus 1 into 2 minus 2, और डिनोमिनेटर में क्या है? L. So 1 L will cancel. So what is left? ML t minus 2. जब हम डायमेंशन चेक करेंगे, so what we find? These are same. So dimension of left hand side is equal to dimension of right hand side, and by homogeneity principle, if each term is having same dimension, then that relation is dimensionally correct. So this principle says that this relation is correct. Now come to third question. In this, there is a difference. Here is plus sign between these two terms. So there are three terms, s equal to ut plus half at square. One on left hand side, two on right hand side, because these two terms are separated by sign plus. If plus or minus sign is coming, then the term on left hand side will be different from term on right hand side, but dimension should be same for all the terms. First of all, I will take left hand side. Dimension of distance will be L. Here S is representing distance. We know this relation. We have already done in motion in 9th class. So when we come to right hand side, there are two terms. First, I take ut, put the dimension of u and t in this. U is initial velocity, so dimension of velocity L t की power minus 1. Time period t. What I find? This t minus 1 plus 1 will be t की power 0. So only L is left. So dimension of ut will be L. Now come to third term, half at square. Write its dimension. Half is dimensionless constant, so it will not have any dimensions, so I can remove this half while writing the dimensions. Now A is acceleration. Acceleration is given by L की power 1, t की power minus 2. So here is time period t. T is capital T dimensions. and here is square term. So take a square. So what I find when I combine, it comes out to be like this. So in this, these two power are opposite and equal. They cancel each other's effect. So what is left? L. So half 80 square is also having dimension L. So what I find, dimension of S is equal to dimension of another term UT, dimension of third term half 80 square. So all three terms are having same dimensions. As a result of which, by principle of homogeneity, if dimension of each term is same, then that relation is dimensionally correct. So ये relation भी dimensionally correct होगा. Thanks for watching this video. Like, share, subscribe my channel.